I would call this a horizontal launch problem. You're throwing a rock horizontally with a certain speed from a certain height. You didn't actually make this motion map, but everything I do is going to come from this motion map. And notice I've got d sub y over here. Look at this d sub y. Well, the thing we are actually asked to find is called the range. The range is the horizontal displacement. And I'll label that explicitly here. The horizontal displacement, how far did the thing move horizontally? Which I'll call d sub x. That's the range. That's a vocab term that you need to know.
Why do they do that? Why is the range?
Okay, so the first and most important idea, the single most important principle, which I'm really going to emphasize in this first video recording, and I'm going to emphasize less in the next video recording, I'm just going to do it. But the central principle, the only new idea is this. Look at the motion of the projectile separately in the x and the y. You will analyze these motions separately in the x and the y. And we're going to take advantage, for example, of the fact that the horizontal velocities, as you can see, are always constant and the vertical velocities change. The horizontal spacing is constant. So I'm going to start writing knowns and unknowns here. My v initial in the x is 4 meters per second. I'm asked for d sub x, question mark, and I'm going to write time here. The rule, and I've stated the principle, and the principle is that you look at the horizontal and vertical motions separately. But what ties those motions together is time. They will have the same time, because although those two motions occur separately, they occur at the same time. Now think about this as I jump in, but I'm now going to look at just the vertical motion. And the hardest thing for people to write down that they don't see, because it's moving in the beginning, think about this for a second, but the initial y velocity, the initial vertical velocity is what? It's 0. That's key. People don't see that because it does have this initial velocity right here. So they're uncomfortable writing any kind of initial velocity as 0. But if you think about it, the initial vertical velocity is 0. The acceleration in the y is negative 9.8 meters per second squared. The displacement in the y, you may be tempted. Hopefully you can see that the 120 meters is a vertical idea. That is a vertical quantity. But make it negative because this object falls downward. So negative 120 meters. And I want to find time. And that is the thing which will link these two. Now, super important. The only equation you'll ever use in the x, because this is constant velocity, is dx equals vx times time. That's the only equation you will ever use in the x for a projectile. Now that's rare that I can say that with any kind of problem solving. In the y, the equations will vary. The one that's most appropriate here, I think you can see, is d equals v initial times time plus 1/2 at squared. And if we just do a quick run through of knowns and unknowns, and I'm asking somebody to crank out a time for me right now. I'm hearing 4.95 seconds.
Yeah.
The displacement is given. This all becomes 0. The acceleration's given, and we're just trying to find the time. And the time, which is what's going to link to the x, is, I'm hearing 4.95 seconds. That's not my final answer, but you can see how that quickly gives me my final answer. Because after all, it's d sub x that I want. So I just take this time and I plug it in here, and you get a final answer. 19.8 meters I'm hearing, which is roughly the 4 meters per second times the time of 4.95 seconds.